Hi students, today we have another experiment for 12th grade students, that is meter bridge. Meter bridge, it is a practical form of Wheatstone's bridge. A Wheatstone's bridge consists of 4 resistors P, Q, R, S. These 4 resistors are connected like in this figure, and between the two junctions B and D, a galvanometer is connected. This is a galvanometer, and between the two junctions A and C, a cell is connected through a key. So P, Q are the value of the resistances connected to the upper branch, and RS is the resistances connected at the lower branch. This is Wheatstone's bridge, and already you know in theory the condition for balancing the Wheatstone's bridge is P by Q equal to R by S. Means the ratio of these two resistors P by Q, if it is equal to the ratio of these two resistors R by S, then it is called a balanced Wheatstone's bridge. At that balanced condition, no current flows through the galvanometer. Galvanometer will show zero deflection because potential at the point B and D will be same. There will be no potential difference between B and D, so no current will flow through that galvanometer. So the current coming from the cell after reaching the junction will split into only 2 branches. One branch will flow through P and Q, the other branch will flow through R and S, and they will combine again here and come to the main circuit. So for balancing the Wheatstone's bridge, the condition is P by Q equal to R by S. Now, the practical form of this is Wheatstone's bridge is meter bridge. The meter bridge consists of a 1 meter length, high resistance manganese alloy, a wire of high resistance of 1 meter length. It is made up of manganese, a material alloy with a low temperature coefficient of resistance. It is fixed on a wooden box, and on the wooden box there are 3 metal strips. 2 are L-shaped, another L-shaped. The middle one is straight one. All together is connected on a 1 meter length wooden box, and a meter scale also attached parallel to this 1 meter line, 1 meter length high resistance wire. So this black colored line is the 1 meter length high resistance wire, and there are 2 gaps between the metal strips. One gap is here at the left side, another gap is here at the right side, and there are screws for connecting the wires. 1, 2, 3, 4, 5, 6, 7 screws are there. For giving the connection, first of all, we have to make the primary part of the circuit. That is, from the left end, take one wire, connect to a cell, from the cell to a key, plug key, from the key to the other extreme end of that 1 meter line wire, which is on the wooden board. So primary circuit is very simple. From the left end means the first screw, take a wire to the cell, from the cell to the key, from the key to the other extreme end of that 1 meter line, a high resistance wire. And to the 2 gaps on the between the metal strips, the first gap connect a resistance box. The other gap connect the unknown resistance. Suppose X is the unknown resistance, the given wire, high resistance wire. And from the middle of this, the straight strip of metal, at the middle there is one screw. From that connect to a galvanometer, from the galvanometer to the jockey, and the jockey can be moved on that 1 meter length of the wire. So if the jockey is touching at this point, then this will act like the resistance P, and the X will act like the resistance Q, and this much length of the wire will provide some resistance that will be at the place of R, and the remaining part of the length of the wire will be acting as the resistance S. Suppose the meter bridge wire, this 1 meter length wire, it is having resistance per unit length small r, small letter r, this much O. That is, for 1 centimeter, if you are cutting 1 centimeter piece of this wire, it will be having a resistance RO. Then if you are taking L length of this wire, it will be having L into RO. Okay. So after making the connection like this, means once again the primary connected to the cell with the key and to the other extreme. First gap connect to a resistance box, second gap unknown resistance. From the middle screw take to galvanometer, from galvanometer to jockey. This is the connection. And test the jockey at this left extreme point. The galvanometer will show deflection in one side. Then test the other end. Galvanometer show deflection opposite side, means the connections are correct. Now we can start doing the experiment. First of all, take some resistance from the resistance box, remove some key. It means we are inserting some resistance, say some 50 ohm resistance is included in the circuit after removing some key from that resistance box. Then move the jockey on the 1 meter length until the deflection in the galvanometer becomes 0. Means it is balanced. At that time, if L is the balancing length, that much L length of the wire will have a resistance equal to, resistance will be equal to L into R. The remaining part of the wire will be 100 minus L, because total 100 centimeter, into R will be the resistance of the remaining part of the wire. So this is P, this is the place of Q, this much L into R is at the place of this R, and this 100 minus L into R will be at the place of S. So if the galvanometer is showing 0 deflection, means it is balanced resistance bridge. So P by Q means in this circuit is R by X, and this is at the place of R by S. So L into R divided by 100 minus L into R, 100 minus L into R. This R will get cancelled, same. So the equation becomes R by X equal to L divided by 100 minus L. So the unknown resistance X can be calculated. X will be equal to R into 100 minus L divided by L. So X, from this equation, X equal to R into 100 minus L divided by L. So for doing the experiment, first we remove some resistance, get the balancing length L. Okay, then calculate the unknown resistance by using the equation R into 100 minus L by L. Means for doing the experiment, you need a table. The table should have a value of resistance, value of L, 100 minus L, then the value of X, unknown resistance. So you need to write down the value of R, L, 100 minus L, X can be calculated by using this equation. First of all, introduce some resistance here, some 50 ohm, get the balancing length, find 100 minus L, calculate the value of X by using this equation. Then remove another resistance, say 100 ohm is removed, 100 ohm, get the balancing length, then 100 minus L, apply the equation, get the value. The value of X coming here should be constant, and take the mean value of that will give the unknown resistance. Okay, if you are getting a question to prove the law of series combination of resistances, two resistances will be given, two unknown resistances will be given. Repeat the experiment. First you do with one resistance X1, the same steps, then disconnect it and connect the second resistance X2, do the same step, and another table, enter the value, find the average mean value of X1 first, then in second step X2, then after that disconnect X2 also and connect two resistances in series, X1 and X2 in series, X1, X2 in series like this, X1, X2. Repeat the same experiment, get the value of L, 100 minus L, after removing some resistance from here, calculate the unknown resistance. If you connect two resistances in series, then the value of this calculation will be equal to X1 plus X2, sum of these two resistors. Repeat the experiment by taking different resistances from the resistance box, get the value of balancing length, 100 minus L, apply this equation, the value of resistance over here, 100 minus L by L, you get the resultant one. If you are getting the question for parallel combination of resistors, first you can find out the individual resistance X1 and X2 separately in two different tables, And the third table again draw the same way, but the last column will be giving the resistance of the two unknown resistors which are connected in parallel, like this parallel combination x1 and x2, and get the balancing lengths 100 minus L, apply this equation, get the value. In this value we are getting here, the resultant of this value we are getting will be equal to x1 into x2 divided by x1 plus x2. This value should be equal to, if you have the individual value of x1 and x2, already we got it before, apply that value x1 and x2 by x1 plus x2. This value and the value you are getting from the experiment both should be equal if it is parallel combination of resistors. Now you can see the same thing in the demo. Okay, this is the meter bridge which is used for finding unknown resistance. It mainly consists of 1 meter wire. This is 1 meter wire of high resistance, high resistivity and low temperature coefficient. It is made up of manganese alloy, and there are 3 strips of metal here, one L-shaped strip here and another one straight and another L-shaped one with the 2 gaps. Here there is one gap between the metal strip and here another gap between the metal strip. And here also there are 2 circuits, the primary and secondary. The main circuit is the cell positive, dry cell positive is connected to one terminal here at one end of this meter bridge, and through a key, plug key, the other end of the plug key is connected to the other extreme end of the meter bridge. Okay, then to the first gap here connect a resistance box. A resistance box is connected. Okay, one terminal to here and the other point to the next end of the gap, and the other gap we connect the unknown resistance. This is a wire of nichrome of high resistance. Then at the center of this straight strip there is a screw here, connect a wire to the galvanometer and from the galvanometer to the jockey. To start the experiment, first insert the plug key, okay, then check the balancing point on either side, touching either side of the galvanometer. It is moving towards right side, and touch other extreme point. And see the balance, the galvanometer deflection in opposite direction. So the connection is correct. Then insert some resistance in the box. So that is included here in the gap. Now it is 5 ohm resistance is included. Then move the jockey until you get the 0 deflection. So it is coming 0 deflection at 78 centimeter. So we have to measure that 78 centimeter from the left side where we connect the positive of the cell. So where you connect the positive of the cell, from there you have to count the distance, the length of the wire. So it is 78 centimeter is the balancing point L, and 100 minus L we can calculate from that. By using that equation we can find out the unknown resistance if you know the balancing point. To repeat the experiment, remove one more resistance. Suppose I included 15 ohm. Again the balancing point will change, and find out the new balancing point, and again find L and 100 minus L, find out the unknown resistance. That will be equal to this resistance R into 100 minus L divided by L. Okay, for doing the experiment for series combination, instead of one resistance here, connect 2 resistors in series between these 2 points. And for proving the parallel combination of resistors, connect 2 resistors in parallel between the same 2 points. And the steps are same, procedure is same. First remove resistance from here and get the balancing length, find the unknown resistance. Again remove one more resistance, find the balancing length, repeat for 5 different values and find the average of the unknown resistance. Okay.